Hi everyone, welcome back to PULLAS Academy. This is physics class for ECET students by Kiran Kumar Adar. Today we are going to discuss about part 7 video in kinematics. In this video we will discuss about the oblique projectile. So this is the most expected area in kinematics. That's why machine should concentrate on this topic, because in the previous ECET exam, so the number of times repeated from this area, that's why machine should focus on this area. Okay, no? Right. Let us discuss about the oblique projectile. Actually, this is simply called as projectile. These projectiles are, we have two types. One is oblique projectile. Second one is horizontal projectile. So, what is the difference between these two projectiles? We will discuss clearly. But from this video we will discuss about the oblique projectile. In the next video we will discuss about the horizontal projectile. A small difference between oblique and horizontal projectile. Actually, oblique projectile stands a body which is projected into air with some velocity at an angle theta with the horizontal. If the angle is always less than 90 degrees, then only that projectile is called as oblique projectile. Okay, that means oblique projectile is a body that is projected into air with some velocity, and how to project it? It makes some angle theta with the horizontal, and that angle is always less than 90 degrees. So that projectile is called as oblique projectile. Whereas what is horizontal projectile? Just a small difference. So between these two, a body which is projected horizontally from certain height is called as horizontal projectile. That means it is projected along horizontal direction. So it is projected at some angle theta with the horizontal. That's the difference. A small difference. It is projected at some angle theta with the horizontal, but it is projected along horizontal. Okay, in the next video we will discuss clearly. Now we are going to discuss about the oblique projectile clearly. Okay, listen carefully, all of it. Actually, according to the definition, so a body which is projected into air with some velocity at an angle theta with the horizontal which is less than 90 degrees is called as oblique projectile. So example is here. What are the examples? For example, a body or a cricket ball. Throwing cricket ball is one of the example of oblique projectile. If you throw a cricket ball, so that is one of the oblique projectile, because this projected ball makes some angle theta with the horizontal. So that's why it is considered as an oblique projectile. For example, a bullet is fires from the gun. That is also one more example of the oblique projectile. In this way, if any object, not only cricket ball, if you throw a stone into air, that is considered as oblique projectile. Okay, so now we will discuss clearly about oblique projectile. So what is the concept here? Listen carefully. This diagram is very important. Each and every concept is understood from the diagram. That's why machine should focus on the diagram. If you understood this diagram, every concept about the oblique projectile is very easily understood. Okay, each and every concept you have to understood in terms of this diagram. Okay, right? So listen to me. For example, this is one plane. This board is. I consider this board is divided into two components. One is x-axis, second one is y-axis. Okay, now these two are the known directions here. So the superposition of, or the combination of these mutually perpendicular x and y-axis stands the plane. Okay, and that means oblique projectile is a body in a plane. But in the previous videos we have discussed vertical motion. That means the freely falling body and upwards projected bodies are moving along a straight line, but this is moving in a plane. That's the difference between freely falling body, upwards projected body, and oblique projectile. Oblique projectile is a body in a plane, motion in a plane, but freely falling body is a body, a motion in a straight line, whereas upwards projected body is a body, it is motion in a straight line. That's the difference between these all types of bodies. Okay, now listen carefully. Now if you consider any object that is project, this is called as, this x-axis always stands the horizontal direction. If you consider any object, that object is projected. So suppose one object is projected with some velocity into air at an angle theta with the horizontal. This is horizontal. If you project it along this slanting line, so that is considered as an oblique projectile. That means it is projected into air, projected with some velocity. Suppose u is a projected velocity, this is a point of projection, here velocity is u, okay, at an angle theta with the horizontal. So that's why this theta is less than 90 degrees from the diagram. So that's why this is called as oblique projectile. When any object is projected like this, that is oblique projectile. When you projected this body is moving along this slanting line. So by the application of external force, but here not only acting external force, here here gravitational force also acting on this body. Under the influence of gravitational force, this resultant force is acting on this body. Due to this resultant force, this body moves along this curve line and finally reaches on the ground. This is ground. Okay, now this is x-axis stands the ground here. When you projected this body, due to gravitational force and applied external force, this body moves along this curve line and finally reaches on the body. Okay, now this is a traveling path of oblique projectile. Okay, so this is called as, actually this is parabola. That means the trajectory of the oblique projectile is parabola. Very important point. What is the trajectory of the oblique projectile? Trajectory means what? Traveling path. So the traveling path of the oblique projectile is parabola. So this is very important point here. Parabola. Parabola stands for the trajectory of the oblique projectile is parabola. Next, one point we got, that is the trajectory of oblique projectile is a parabola. Clear? Right. So now we are going to discuss clearly about this oblique projectile. Okay. Actually here this body moves along this slanting line. That means here this is an unknown direction, but here for projectile, here known directions and x and y axis. That's why this is horizontal direction, this is vertical direction. That's why this motion is divided into two parts. One is horizontal, this is called as vertical motion, this is horizontal motion. We will discuss two types. So this oblique projectile, one of the motion is called as horizontal motion. It is divided into two parts. One is horizontal motion, second one is vertical motion. So the important points for horizontal and vertical motion is, along horizontal direction its motion is uniform. So here point is what? The actual point is along horizontal direction, or so here in this horizontal motion, along horizontal direction its motion is uniform. That means uniform motion. What is the point? Uniform motion means velocity is always constant. In uniform motion, what is constant here? Velocity is constant. That means at any point velocity of this oblique projectile is constant along the horizontal direction. In the same way, in the vertical direction its motion is called as uniform acceleration. That's the difference between these two. So if it is divided into two parts, one part is called horizontal motion, second one is vertical motion along vertical direction. So its motion is considered as uniform acceleration. Uniform acceleration means velocity is not constant. Here velocity not constant. Acceleration means velocity changes. But what is constant? Acceleration is constant, but acceleration velocity is not constant. That's the difference between. That means along x-axis always velocity is same, but along vertical direction acceleration is constant but velocity changes. How to change the velocity with respect to the y-axis we will discuss clearly now for this oblique project. These are the important points for oblique projectile. One is the trajectory of the oblique projectile is parabola. Along horizontal direction its motion is uniform. Along vertical direction its motion is uniform acceleration. These are the important points. So for oblique projectile, first we will discuss the motion of this oblique projectile at the point of projection. This is the point of projection. This point is O is at origin is the point of projection. This is I consider case 1 at the point of projection. This is also called as initial position. This is also called as initial position. Listen carefully. At the point of projection, the velocity is u. This is the initial velocity. It makes some angle theta with the horizontal, and this is the direction of the velocity. This is the magnitude of the velocity. Actually, this is unknown direction in a plane. So it is divided into two parts. We know already I explained in the vectors. Any vector is possible to resolve it into two components. One component is acting along one known direction. Second one is acting along the another known direction. That means it is divided at the point. If it is divided into two components, one is denoted by ux, that is equal to u cos theta. In the same way, it is divided into one more component that is acting along y-axis, that is u sin theta. Okay, now this is horizontal component, this is vertical component. That's why here understood. So at the point of projection, horizontal component of initial velocity, it is simply is denoted by ux. Ux is equal to u cos theta. So this is one of the component, means a part of the vector. This u velocity, one part of the vector is u cos theta acting along x-axis. That is horizontal component of initial velocity. Next, along vertical direction, that part of the vector is vertical component of initial velocity, that's denoted by uy. Uy is equal to u sin theta. Okay, now? Next, what is the complete velocity, initial velocity vector at the point of projection? So this is along x-axis, this is along y-axis. In vectors, along x-axis always denoted by I unit vector. Along y-axis is always denoted by j unit vector. That means this is a vector form of this initial velocity vector at the point of projection. U cos theta into I cap plus u sin theta into j cap. This is the point. And one more point here. At the point of projection, along horizontal direction, acceleration denoted by ax, that is considered as 0. Why? Because along horizontal direction, uniform motion. Uniform motion means acceleration is 0. Along vertical direction, its acceleration is uniform acceleration. This uniform acceleration is similar to, we have to consider, so minus z. Why it is denoted by minus z? Because it is moves away from the ground. Any object is moves away from the ground, so we have to consider minus z. Due to the gravitational force, if getting acceleration is acceleration due to gravity, that's why here also we have to consider g. But y indicates minus, it is moves away, means what, it is moves away from the ground, gravitational force acting downwards. That's why we have to consider negative sign. These all are the parameters. One more point here. This is a resultant acceleration, velocity. What is the angle between acceleration and velocity? From the diagram, 90 plus theta is the angle between velocity and acceleration direction. These all are the important points at the point of projection of oblique projectile. Now we are going to discuss one more instant of position. This is, I consider, instant of position P. Okay, we will discuss now that. It is called as at an instant of position. At an instant of position or at an instant of time. So that the instant of position I consider P. It takes time t seconds. At an instant of time t or at an instant of position P. So we will discuss the expression. For example, if you want here velocity, listen carefully, draw the tangent line at the point that indicates the velocity. This is initial velocity. This at this instant of time, the velocity is v. Again, v is not the known direction. It is inclined. This is divided in two components. One is vx, second one is considered as vy. This is vx, this is vy. Okay, that's why here also at divided in two components. One is vx. Vx is equal to always write u cos theta. Why write u cos theta? Because along horizontal direction its motion is uniform at any point here, at the point of projection, at instant of position, at any point on the traveling path, velocity is same, that is u cos theta. But vertical velocity vy is equal to is not constant. Is actually when while moving upwards velocity decreases. Its velocity vy is equal actual formula initial velocity u sin theta minus dt is the formula. From the first kinematic equation after derivation you get it actual. Actual formula is what? What is actual formula? V is equal to u plus at. Here u is equal along vertical direction u is u sin theta. Along vertical direction a is equal to minus g. Already I explained. That means here write minus g into t. That's why you get this equation. Recognize these two equations. So here complete velocity vector is what? So v bar is equal vx I cap plus vy j cap is the velocity vector. So vx stands u cos theta, vy stands u sin theta minus gt. If you substitute you get complete velocity vector. Okay, now here also this is velocity, this is called as acceleration. The angle is what? Again 90 plus theta is the angle between velocity and acceleration. And one more point here, that is acceleration is 0 along horizontal direction. Along vertical direction acceleration is equal minus g. While moving upwards always takes minus, while moving downwards takes positive sign. So that's the point. Now we are going to discuss displacement along when it is reaches to this instant of point. What is the displacement of this projectile is very important. Now we are going to construct that equation. What is that equation? So this displacement I indicated by x. Along horizontal direction displacement is x. For example, reaches to this point P, the horizontal displacement is x, vertical displacement is y. If you want horizontal displacement, just imagine the normal line to x-axis where it is intersect from the origin. This distance is called as horizontal displacement, that is x. If you want this x, how to get this x value? Actually x along horizontal direction its motion is uniform. When its motion is uniform, distance or displacement is equal velocity into time. That's why here just to recognize this formula u cos theta into t is the formula for horizontal displacement. So this is the most important expression here. For oblique projectile at instant of position, horizontal displacement is u cos theta into t. Okay. Next, after that we will discuss vertical displacement y is equal. So if you want vertical displacement, that is similar to u sin theta into t minus of gt square. This is the expression for vertical displacement. Okay, now do you know how to getting this equation? Actually equation is s is equal to ut plus half at square. This is second kinematic equation. S is displacement, but vertical displacement, if you draw the normal line to y-axis from the origin, this displacement is y. That's why s is called y. This u along vertical direction velocity u sin theta. This when it is reaches to this instant of time, the time is we consider t. That's why u sin theta into t. Next, a is equal substitute minus z, plus into minus minus of gt square. That's why you get this equation. This is a vertical displacement of this projectile. Okay, if you substitute this equation in this equation, finally you get y is equal, you get this formula. That formula is here. So tan theta into x square minus g by 2u square cos square theta. What is the formula here? G by 2u square cos square theta into x. So this is the formula for displacement. Okay, now if you substitute this equation in this equation, so you get displacement of this projectile. Okay, now? So projectile is a body in a plane. That's why combination of these two displacements, so you get the complete displacement of this projectile. That is denoted by, this is the most important expression. Y is equal tan theta into x square minus g by 2u square cos square theta into x is the formula. Okay, in this formula, so now you have to understand tan theta. So is one of the constant, that's why we have to consider tan theta is equal to A, and G by 2 U square cos square theta, that is similar to B. If you substitute these two in the equation, y is equal to ax square minus bx. Okay, now this is the formula. Y is equal to ax square minus bx is the formula for displacement. Okay, I am very sorry here. When you substitute this equation in this equation, you get not x square, x tan theta into x. Here you get x square. Sorry. So when you compare, then you get ax minus bx. Okay, y is equal to ax minus bx square is the displacement of this projectile. This is called as, actually this mathematically this equation is parabola equation. Parabola equation. That's why we concluded the trajectory of this oblique projectile is parabola. Okay, so these are the important expressions at instant of position. Here also the angle between velocity and acceleration is 90 plus theta. So this is velocity, horizontal velocity, vertical velocity, total velocity, acceleration along horizontal, vertical acceleration, displacement along horizontal direction, displacement along vertical direction. This is the total displacement of this projectile, oblique projectile. So this is the simplification of this equation. Here what is expression for this constant tan theta? This expression for B is d by 2u square cos square theta. Okay, finally here proved the trajectory of this projectile is parabola. Now we are going to discuss one more case, that is case 3 at the point of highest point. This is highest point is called as maximum height of this projectile here. So here understood at the maximum height, if you want velocity, draw the tangent line. That is, this is a complete velocity. So along vertical direction velocity is 0, Vy is 0. But horizontal velocity and total velocity is similar, that is V is equal to Vx. This is velocity direction, this is acceleration. The angle between velocity and acceleration is 90 degree. If you want expression in the same way, you have to write Vx equal to u cos theta. Always u cos theta, but Vy is 0. So if you want displacement, use the same formula, but the taken time is more. That's why this displacement, horizontal displacement, it is increases. What is vertical displacement also increases because the time is increased. In this way we have to measure. So this is one more case. And one more case, if you want to indicate one more instant of position, here you want velocity, this is the direction of velocity. So this is velocity, this is horizontal velocity, always Vx is equal to u cos theta, but vertical velocity Vy is equal u sin theta plus dt. A is equal to substitute plus d. Why? Because it is moves towards the ground. That's why Vy is equal to u sin theta plus dt is the formula. In the same way displacements also measure, but what is the formula? This is velocity, this is acceleration. So that's why what is the angle between velocity? This is acceleration direction, this is velocity. That means 90 minus theta is the angle between velocity and acceleration. At the point of projection also similar. This is the direction of velocity. Again the same way you get the expression. These all are the different cases of oblique projectile. Okay, now we are going to some more important parameters. Concentrate here, most of the times asking question here. The first important parameter is time of ascent. First one is for time of ascent. What is the expression for time of ascent here? For oblique projectile, time of ascent Ta is equal to u sin theta by Cm. So what is the formula here? U sin theta by Cm. If you want to the derivation, V is equal to U plus 8 is the expression for oblique projectile along vertical direction. Here this V, when it is reaches to maximum height, its velocity is 0. So U is equal to U sin theta. A is equal substitute to minus Z. That means you get minus Ta. The taken time is considered Ta. That means dTA is equal to U sin theta is the formula. Then Ta is equal to U sin theta by G is the expression for time of ascent. This is the expression for time of ascent. In the same way, here one more expression. So that is time of flight. One more expression is what? Time of flight. So in the same way, derivate from the by using kinematic equation here. Just recognize the formula, that is 2u sin theta by z is the formula for time of ascent. A small difference. This is u sin theta by z. It is 2u sin theta by z. This is the expression for time of flight of oblique projectile. Okay, for oblique projectile, one expression is time of ascent, time of flight. Now we are going to discuss about the maximum height. What is maximum height for oblique projectile? At a certain height, the vertical component of velocity is 0 for oblique projectile. That certain height is called as maximum. So if you at a maximum height, vertical component of velocity is 0, known parameters. Okay, along vertical direction, initial velocity uy is equal to u sin theta. Along vertical direction, acceleration always similar to minus. Okay, along vertical direction, when reaches to this point, this is vertical displacement y, but we consider this is considered as h max. This is one of the height, that's why I consider h max. If you want an expression by using third equation, v square minus u square is equal to 2as. Here v stands vy stands 0, 0 square, u stands uy, that is u sin theta whole square stands u square sin square theta. Now a is equal to substitute minus g, that means minus 2g into h max is the form. Okay, now this negative sign cancel, remaining is u square sin square theta by is equal to 2g h max is the form. We need expression for h max, write as a subject h max is equal to u square sin square theta by 2g. What is the formula for h max here? U square sin square theta by 2z is the formula for h max. Okay, the most important expression, most time repeated on this formula. U is the projected velocity, initial velocity. Theta is the angular projection, g is the known constant. Just you know this angular projection and you substitute in the formula, you get maximum height reached by the oblique projectile. Okay, right. So here next set one is called as horizontal range. The next parameter also important here. These two are the most important expressions. Horizontal range, it's denoted by r. Okay, in the diagram, so here from this point projected, this is a striking point, this is a come along horizontal direction, this displacement is maximum. That maximum horizontal displacement by this projectile after taken time of flight is called as horizontal projectile. In a time of flight, the total horizontal displacement is range. That means from O to A is horizontal. So then if you want expression for horizontal range, that is similar to along horizontal direction displacement is. Along horizontal direction its motion is uniform. If its motion is uniform, distance is equal speed into time. Along horizontal direction always velocity is u cos theta. Into taken time is time of flight. From O to A, the total taken time is time of flight. That's why u cos theta into t is the formula for horizontal range. We don't know time of flight directly. So then substitute this formula. Already we have explained what is time of flight of oblique projectile, that is 2u sin theta by z is already I explained. This is similar to u into u square 2 sin theta cos theta by z is the formula for r. From this expression here, r is equal to u square 2 sin theta cos theta is called as sin 2 theta. Sin 2 theta by z is the formula. So this is called as a range formula. Okay, the maximum. If you compare these two equations, u square same. But here sin square theta, this is sin 2 theta, that's the difference. But here 2z, here g, that's the difference between horizontal range and maximum height formula. Here also theta stands angular projection, u is the initial velocity or projected velocity, g is the constant. So from this equation where theta is equal, substitute 45 degrees, then 2 theta stands 90 degrees, sin 90 is 1, that means r becomes maximum. When r becomes maximum, where theta is equal to 45 degrees, that's the important one. That means what is maximum range equation? Just substitute theta is equal to 45, you get sin u square by z, because sin 2 theta value is 1. So then r maximum equation is u square by g, in this way understood. So this is about the maximum height and horizontal range. Here important relations are relation between maximum height and range. So the relation is what? Here h max is equal r by 4 is one relation. And one more point here, tan theta is equal 4h by r. This is the relation between, it is also indicates relation between h and r. tan theta is equal to 4h by r, or h max is equal to r by 4, where theta is equal to 45. At 45 degrees, h max is equal to r by 4. Otherwise, we don't know this angle, then use this formula. Tan theta is equal to 4h by r is the relation. So next, one more relation here. So that relation indicates r is equal gt square by 2 tan theta. So this equation indicates relation between r and t. So these all are the important relations here. Relation between h and r. So this is the most important relation here. Previous questions are repeated from this area. You have to concentrate on this area. Okay. And one more point, sometimes asking, for example, here at this point asking what is relation between any two parameters. For example, here it makes this velocity makes theta with this horizontal, then at that point if you want relation, that is tan theta is equal Vy. So here Vy by Vx is the formula, opposite side is Vy, it is parallel to, this is the adjacent side Vx, this is a formula. If you know Vy Vx, then understood what is theta. Sometimes asking x component, y component is giving, asking this theta value by that equation. In this way we have to measure. So these all are the important expressions for oblique projectile. In this chapter, these all are the important expressions. You have to concentrate on this expression. You have to recognize these formulas. One is horizontal displacement at instant of time, x is equal u cos theta into t. Vertical displacement at instant of time. So this is oblique projectile displacement ax minus bx square. From this formula only understood the trajectory of the oblique projectile is parabola. Here a formula is tan theta, b formula is g by 2u square cos square theta. Here derivative this formula, time of ascent is u sin theta by z, time of flight is 2u sin theta by z. Maximum height formula, this is most important, these two. So u square sin square theta by 2z and r is equal u square sin 2 theta by z. Here relation is tan theta is equal 4h by r is the relation between h and r. Relation between r and t is r is equal gt square by 2 tan theta. So one more, at a particular angle theta is equal 45 degrees, h maximum is equal to r maximum by 4. So these all are the important expressions. You have to focus on this area. Now we are going to discuss some previous ECET model questions. Okay. So these are related to oblique projectile. So the first question is repeated in ECET 2016 TS paper. Simple question. The maximum height reached by a ball thrown at an angle 60 degree to the horizontal with an initial velocity 9.8 meter per second is given. Then g is equal to 9.8 meter per second. Given that, so g is equal. So asking maximum height. What is asking here? Maximum height. What is the formula for maximum height? So this is a maximum height formula. Already I have explained that concept clearly. H max is equal to u square sin square theta by 2z. Here u is given. What is given value? This is u 9.8. U is equal to 9.8 meter per second is given. And what is theta is given here? 60 degrees given. And small g value is given 9.8. Substitute and simplify, you get it. Just you know the formula, it's very easy. U is equal 9.8 whole square means what? 9.8 whole square into sin square. What is theta? Is 60 degree. So divided by 2 into g value is 9.8. 9.8 square is cancelled. Remaining is 9.8 by 2 means 4.9 to 4.9. Sin 60 value is root 3 by 2. Root 3 by 2 whole square is 3 by 4. You get root 3 by 2 whole square is 3 by 4. That means after simplification, so you get the answer is 3.675 meter. If you cancel it, you get answer 3.675 is the maximum height. So this fourth option is correct. One more question. It is repeated in ECET 2015 paper. A missile is fired for maximum range with an initial velocity of 20 meter per second. G value is given. The range of the missile is asking. What are the given values here? Simple is given. Two values. One is initial velocity 20 meter per second is given. Small g value is given 10 meter per second square. Okay. Now maximum range is asking. What is the formula for maximum range? Already we have discussed the maximum range here. This is range formula. What is maximum range here? Maximum range means where theta is equal, substitute 45 degrees, you get maximum range. Sin 90 is 1, that means u square by g is the maximum range formula. What is formula for maximum range? That is u square by g is the maximum range formula. If you substitute u value is given 20, 20 square means 20 into 20. G value is 10, 0 is cancelled, 20, 2 is 40. What is answer here? R maximum is 40 meters is the answer. This second option is correct. The next question is repeated in ECET 2015 TS paper. So here, for an object thrown at 45 degree to the horizontal, the maximum height capital H and horizontal range capital R are related as. How to relate it between when theta is equal 45. So given value is theta is equal 45 degrees, maximum height is capital H, range is given R. What is the relation between maximum height and range? So already I explained, this is the formula. That formula is tan theta is equal 4h by r is the relation. Here theta is equal, substitute 45 degrees. Tan 45 degree is equal 4h by r is the formula. Okay, now tan 45 is 1. 1 is equal 4h by r. That means if you simplify, then r is equal 4h. So this is the relation between r and h. This third option is correct. Last question, one more question, that is question number 4 is repeated in ECET 2014 paper. So here the projectile has a maximum range. Given value is for maximum range. That is given R maximum. What is R maximum formula? U square by z. U square by z is given 200 meter. And the maximum height attained is asking. H max is asked. This is a question. So what is the formula for H max here? Already we have derivated that formula. H max is equal, formula based on that formula, u square sin square theta by 2. Okay, now u is not given, theta is not given directly, but given this value. So how can we understood here? If the projectile's range becomes maximum at theta is equal 45. At theta is equal 45 degrees only, the range becomes maximum. That's why indirectly understood here theta is equal 45 degrees. So here in this equation u square by z is given. If you write like this 1 by 2, so here u square by g write separately here. The remaining equation is what? Sin square theta by 2. This is the form. Why write separately? Because u square by z value is given, that is 200. And sin square theta is equal to 45 degrees. Substitute 45 degrees by 2. After simplification you get it. So what is simplification here? 200 into sin 45 degrees is 1 by root 2 whole square. 1 by root 2 whole square is 1 by 2. By 2. Okay, now 2 hundreds and again cancel 50s. That means answer is what? 50 meters. What is H maximum is equal? 50 meters. This third option is the correct. So this is one more repeated problem in the previous exam. This type of questions are repeated in the previous exams. You have to concentrate mainly on maximum height and range, and relation between maximum height and range is the important concepts in oblique project. Okay, so have a nice day. Thank you. Bye.